Okay, so welcome to the next session. We are still on the maintenance schedule program. So I like all of you, welcome to the session. Konnichiwa, and dive into the program. Okay, the next point where we have to look on is on the engine, the starter battery or starter batteries. We always have to check the level of the batteries. So the best is if we can check the level every 3600 operating hour and measure the voltage of the batteries. Important to measure the voltage of the batteries is that we disconnect the batteries from the battery charger. Otherwise, it could happen that we only measure the voltage of the battery charger. So the charger is always with a higher voltage to charge the voltage into the battery or the current flow into the battery. So that's why it's important that we disconnect the batteries and then we measure the batteries, that we get the proper measurement out of it. The level as well on the batteries by themselves, there are marks on. The important point for the batteries is why we need a good battery quality and battery voltage. The battery is not only responsible for the starter, to turn the engine and start the engine. The starter battery are as well responsible for the power supply to the ECU or ICM, so the engine controller unit or injection controller module that controls actually the injection timing and amount of the injectors. That means the power for this controller unit and for the modules what controls the injectors, what spray the diesel into the combustion chamber, are supplied from the starter batteries as well. So in that case, we have here our starter batteries. We have it's called 2 times 12 volt batteries. And they are connected in series. That means the output between the first battery plus and the second battery minus, because here's a bridge in between, is 2 times 12 volt. That means we have 24 voltage power supply out of the batteries. And this power supply supplies the starter to start and turn the engine. And secondly, it supplies here, as I mentioned earlier, the ECU or ICU, depends on how we like to call it, for the injection timing and amount. So keep that in mind, very, very important that we have always good quality from the batteries, especially in winter time when the temperature is very cold and the engine, if it's standing very long, it's cooled down. That means you can have an engine oil temperature of maybe 5 degrees or less, actually. That means the oil is more viscous. That means it's difficult or more difficult to turn the engine. It needs more energy to turn the engine. If the engine is cold, it needs more energy. If the engine is warm, it needs less energy to turn. They're important as well. We have to reach at the start phase at least an RPM of 120 RPM that we can ignite or that we can start the engine. So please keep that in mind, that we always focus on that. The next point what we have is the backup batteries. The backup batteries are in the controller panel. So we have here a picture. This is a backup battery. These batteries are supporting the internal 24 voltage supply of the control panel. That means there's all important 24 voltage supplies are connected to the batteries in case that we have a grid or power fail, that our system not shut down immediately. These batteries will take over the power supply to the controller panel. That means we have the power supply to the PLC, we have as well the power supply to the panel PC, and the power supply to all the components that the whole system still can operate and go into a cool down phase in case of a power fail. These batteries always have to be replaced. Please replace it every 14,400 operating hours. So again, quickly back to these batteries. The batteries are like a backup system. A backup system to keep the controller alive in case we have power fail. In the case of a power fail, all electronic devices will switch off immediately. So, and if our CHP is operating on full load and we will get a power fail and all voltage and all power will trip, that means the CHP will immediately disconnect from the grid and all components will shut down immediately. To compensate that our PC and PLC is not crashing and that we get a safe cool down phase, we need this backup power to keep the controller up and running. So please keep an eye on that, test the batteries, and please replace it. So the 14,400 operating hours approximately every second year, so that we always have this backup system in place. As a standard, we have on the CHP unit different emergency buttons. One is on the panel board, what we can see here. Another one is at the engine controller unit board. Another one should be usual somewhere in the machine house or in the container system outside next to the door. So always check if the emergency button function is working well. So you should do it in the status that the CHP is not operating. So that means that the CHP is on standby. If we do testing on full load, emergency stop means immediately stop and disconnect, reduce load, and stop immediately. That means we will not have any after cooling phase for the engine. We have immediately stopped the engine, what can have a negative impact on the turbocharger and so on. So it's, as the name told us, it's an emergency button. And for testing, please put the CHP on standby, that means without load. Press the button. On the display, you will immediately see the error message of immediate stop emergency button or emergency stop. And please check all of them. So all installed emergency button, so that we make sure every 3,600 operating hour that we check the emergency button. So, okay, then let's go now to the next point. The next point is the oil collection pan sensor. this is a sensor what is at the underneath the engine in the oil pan what is mounted in the frame. Let's see if I can show you that here. So we have here the engine, and then we have here underneath the engine in the frame we have the additional collection pan for oil. So in case there is any damage, leakage or broken hose that the engine oil is not running through the machine house, it will be collected here underneath in that pan. And in that case, not only the engine oil, as well if we have some leakage on the diesel system or if we have some leakage on the water system. At the position here in the frame we will find a sensor looks like that sensor. It's connected here with a wire with the plug, and this sensor here on the bottom, this is actually the liquid sensor what can measure if there is liquid in the pan. So, and this will again give an arrow and stop the system. So in case we have a leakage on the water system or on the oil system or in the diesel system, and the leakage sensor detect any kind of liquid in the bottom underneath the engine, it will switch off the engine and stop. So that will prevent as well, if we have a leakage on the oil, that not the whole oil will disappear and the engine will still running until the oil pressure drops and get further damages. The oil leakage sensor will detect that there is a liquid in the bottom oil pan to switch off the engine. So this sensor must be tested every 3,600 operating hours. So to test the sensor, so the sensor is the sensor is, the leakage sensor is designed as a vibrating level switch. So these two fins here, what we can see here, both are kind of vibration. They both have a very fine vibration. And if the liquid comes in between, the vibration, so the density of, because there's no air anymore, now we have liquid, so the vibration is changing. And in that case, the sensor will detect that there's liquid and switch off the CHP. So the CHP, for testing that, the CHP must be switched on during testing. So it's more than enough if we run on diesel mode, or as well if we start the engine and it's only in warm up or synchronization, we already can test the sensor. To test the sensor, we can touch with the hand the two fins, and that what will happen is that the vibration will change as well, like it's the same as when a liquid is, the density of a liquid will be in between, and the sensor will show up an arrow, so the CHP switch off and will show up there on the display, and then we know that this sensor is working. So please check the sensor every 3,600 operating hour. It's only a check, so that we ensure that the protection system works. Well. So now we go into the gas system. So as usual with all other components on the CHP or on the whole plant, check always virtual if there is any damage, crack, loose balls, vibration on it, so that we check every 3,600 operating hour if we can see any problems and react in advance. So, for example, if any kind of bolts clamp is loose already and we get more and more vibration on the gas pipe, it can force further damages on the equipment or as well leak it out of the gas pipe. So check it always. If there is something what you can see already, fix it immediately. Otherwise we can get further problems on it. So then the next point is measure the cooling cycle antifreezing concentration. As far as I know, you don't have a cooling cycle for the gas from Schnell. I think it's only, that's what I mentioned here in red, if you have a gas treatment system of Schnell. The gas treatment system of Schnell works with active carbon filter and with a gas cooling system to get the condensate out of the gas. So if you operate with like an air con system to cool down the gas, then for sure you have to check the water system, take a sample and ensure that you have enough antifreezing liquid in the water cycle, that it's for I don't know what's the target in your area, but that is designed for -27 degrees to ensure that the water does not get frozen and breaking pipes or damaging something on the water system. The gas filter element. Always check the gas filter element of condensate. So in case, for example, if we have a gas cooling system in front of it and maybe a condensate trap, then and something is damaged or blocked or not working, then we can get condensate into the gas filter. So if the gas filter is wet, that's a clear indicator that we have a very wet gas, and we have to check then all the equipment in front of it, as well the gas cooling system or the condensation trap. So dirt and condensate will damage your gas solenoid valve and gas actuator and the flame arrestor. So if you get wet gas or condensate with dirt together and maybe H2S into the three different components like the gas solenoid valve, the gas actuator and the flame arrestor, the solenoid valve gets dirty and maybe cannot close the valve properly anymore, or as well it could get stuck. The gas actuator depends on which kind of gas actuator is installed in the system. Some are working like a cylinder in each other, some are working like a flap, so that one can get dirty, can happen that it's not closing properly anymore, or open, that is not opening properly anymore. Flame arrestor, remember a flame arrestor works to, in case there is ignition of biogas at the engine, and this burns backward into the gas supply system. Then we have the flame arrestor in between that blocks that the fire can, or the combustion, the fire can go into the gas system. So that means this flame arrestor is a very fine mesh of special material, and if you get dirt in this mesh, it's very fine, it's difficult to look through it, and you get dirt and stuff in it, you get blockage there. So it can block the arrestor, and the arrestor to clean up, it's not that easy, but you can clean it, but it's a lot of work. So always make sure that the gas filter is cleaned properly. So we have here the gas filter. And important here on the gas filter, that the gas filter sits in the dip of the housing on the bottom and as well on the top. You see here the filter will sit here, so that means around the filter there will be always an air gap or gas gap. So if the gas comes in, the gas can go all over around the filter. It's not sitting, if the filter is sitting directly in front of the hole of the pipe, then the diameter of the filter will be only the size of the hole. If we have the gap here in between, the gas can go around the filter and go everywhere through the filter element. So the filter works much better in that position, and we will have less gas pressure drop. So, and then the filter can absorb the dirt, and please check always if you have condensate in there as well before then it goes to the solenoid valve. Yeah, gas blower. There's again at the point here in red. I'm not sure if all plants in Japan have Schnell gas blower, but in case we have a Schnell gas blower, Schnell recommend that you have to replace the gas blower every 14,400 operating hour. This is a general thing from the manufacturer that they say, okay, you have to replace it because the gas blower can start to leak afterwards. If you do always a testing on the gas blower of if the gas blower is leaking, so if you have a test spray, a leaking test spray, it's like a spray, like a soap spray. It gives you like a foam, it's a liquid with like a foam on top of the surface area where you spray on it. And when you get small bubbles, then you know there's a leakage, that some gas comes out. So if you use that spray and you go over all areas where are the flanges connected, where are the rubber seals or the gaskets in place, then I would say you can run this gas blower as long as it survives. Because why should I change a running system if everything is 100% working well? So I think we can keep the gas blower much longer if we do a proper testing, that we ensure that there is no leakage on the gas blower. So we have to test all the bearing on the bearing seals of the shaft of the gas blower. We have to test all gaskets, all flanges, all connectors, as well where the gas blower turbine is fitted together, that we test that with a leakage spray and ensure that we don't have any leakage in the gas blower. Please remember, biogas is biogas and oxygen together. So if biogas get into the air with oxygen, then we can get explosive gas combination. So you must have the right ratio about oxygen and methane, so biogas. But it could happen that you get a combination out of both together, that it could be explode. That's as well always important that you have the right machine house or container air circulation, that we always get enough oxygen or air into the machine house and suck or blow the dirty air out of the machine house. So, but keep that in mind and keep a proper maintenance and check the gas blower properly. Ensure if you hear a noise that the gas blower making something noisy, that for example that maybe a bearing of the blower get broken or is on the way to get broken. As well, maybe you hear noise from the turbine at the gas blower. then it's worth to maybe replace it and check the old gas blower and to ensure that we not get any further problems or shutdown phases. Yupa. So we have here the different gas blowers. This is the two different gas blowers, what is a standard from Schnell. So we have here the connectors where we can pressure inlet and outlet of the gas blower, what we mentioned earlier as well. So we have here the turbine, here the motor. So we will have here a bearing inside of the motor. Then we have here the housing for the turbine. There is a flange, there is a flange. So we have to test leakage of that area here. Then we go to the next flange and the blower here. The blower housing here is connected with each other. So we have to test that area. And then we have the inlet area where we have a flange here, a flange at the beginning, and then the piping again. So test all these components here where we have the gasket or flange in between. So on the bottom gas blower, we have actually almost the same situation. We have the inlet here, we have different flanges. It goes into the housing. Here is in between is a bearing. Then we have the main housing of the turbine here. That means here is a gasket in between as well. So we have to test the leakage on that side. Then we have the outlet pipe with a flange, and then goes to the supply pipe system. Okay, so I recommend to do that not only on a Schnell gas blower. If you have a centralized gas blower or separate gas blowers on your side for supplying gas to the CHP, please keep an eye on that, test it, listen to the noise, listen to see if you have any vibration on the system, and then test it with the gas leaking spray. Okay.